Alright, so we're starting Chapter 4. Chapter 4 is dealing with, first of all, we talk about divisibility and factors. So you guys, we will talk very quickly about some of the divisibility rules, and then we're jumping right into factors. We're talking about exponents and where they fall with order of operations. That should be a review for you guys. Then we get into prime factorization and greatest common factor, simplifying fractions, and then we get into exponent rules. We're diving back into exponents. All right, so that's kind of what Chapter 4 is. If we take a look at the first section, so today is 12:16. We're looking at Chapter 4, Section 1. This is divisibility. And factors. Come on. All right. When we talk about the word divisible, an example might be 6 is divisible by 3. What does that mean? What does it mean that it's divisible by? Mia? Well, 3 can go into 5 also, but 3 goes into 6. Pardon me? Evenly or without remainder, right? So divisible by means that, in this instance, 3 divides into 6 evenly or with no remainder. That's really what it means. With no remainder. So divisible means that a number divides into another number, leaving no remainder. God bless you. So divisible means that a number can divide into another number, leaving no remainder. I'm going to go through a couple real quick divisibility rules, because as we're doing as we are doing what we're going to be doing with factors, prime factorization, greatest common factor, you knowing our divisibility rules is going to make this a lot faster. All right, so let's talk about some of our divisibility rules. I'm hoping that this is a review for you, that you remember these. Let's do 2. How do we know if a number is divisible by 2? How do we know if a number is divisible by 2? Jack? If the last digit is even. If the number is even. All right. How about 3? How do we know if a number is divisible by 3? Pierre? Some. All right. Yep. So if we add all the digits in the number together, and that sum is divisible by 3, then the original number is divisible by 3. How many of you guys remembered that? Awesome. 4 we don't use all that often, so I'm just going to go through with you guys the most common ones. Because if a number is divisible by 2, a 4, it's going to be divisible by 2. All right, how about 5? How do I know if a number is divisible by 5? Alex? Excellent. The last digit is 5 or 0. How about 6? Who remembers 6? Alex, remember it? Excellent, that's right. If the number is divisible by 2 and 3. 4 and 8 are similar. They're harder to remember. I don't always remind you of them. All right. Like I said, the most common ones is what I want to go through. So 9. If a number is divisible by 9, it's also divisible by 3. So if you don't remember 9, that's okay. But 9 is very similar to 3. Somebody explain 3's divisibility rule to me. Somebody explain 3's divisibility rule to me. It's on your paper. All of you take a look at it. Somebody explain it to me again. Kira? That's the same rule as 9. That's exactly right. So the divisibility rule of 9 is exactly the same as the divisibility rule of 3. If we add all the digits up and that sum is divisible by 9, then a number is divisible by 9. It's the same divisibility rule, but only by 9. So if we add all the digits in the of the number, and the sum is divisible by 9, then the original number is divisible by 9. You're all writing this down. So if you add all the digits of the number, and that sum is divisible by 9, then the original number is divisible by 9. How about 10? How about 10? Aaron? Yep, the number ends in 0. The last digit is 0. So let me give you a couple numbers, and you tell me. I want you to write whether it's divisible or not and say why. What number it's divisible by and why. You guys cool so far? Okay. And it might be divisible by more than one number. But you have to tell me why. So I want you to determine what number. I'm going to put in parentheses S for numbers, because it can be more than one. The following values are divisible by. And how you know. Alright, so my first one is 115. Do each one of them individually. Keep going. I'm going to keep writing them down. Thank you. So you're stating what 115 is divisible by and why you know that. You're stating what 663 is divisible by and how you know that, etc. And it can be more than one number that it's divisible by. So you're checking all of the ones that we went through. 2, 3, 5, 6, 9, and 10. Let's take a look at these. How about 115? What is that divisible by and how do you know that? Angela? Why? Excellent. All right, how about 663? What number is 663 divisible by? Pierre? Okay, so if I do 6 plus 6 plus 3, what does that give me? Is 15 divisible by 9? So what is it divisible by though? 3. So this is just going to be divisible by 3. 3 because 6 plus 6 plus 3 is 15, and 15 is divisible by 3. So that's what I would like you to write. So adjust your description or your explanation. All right, how about 1017? Addison? By both 3 and 9? Okay, so let's show that. I'm going to say 3 and 9 because 1 plus 0 plus 1 plus 7 is 9. And 9 is divisible by 3 and 9. So when you are doing the divisibility of 3, when you're doing the divisibility of 3, when you're doing the divisibility of 9, make sure you show that sum and you prove it mathematically. All right, how about, I think our last one was 282. Who wants to do that one for us? Mateo? So you have to do one, since they're all different rules, you have to tell me individually. So why 2? All right, hang on one second, because the last digit is even, or the number's even, however you want to write that. 3, why 3? So, excellent. So 3 because 2 plus 8 plus 2 is 12, and 12 is divisible by 3. I do want you using that explanation. So I don't want you just to say if you add all the numbers up. I want to see that addition. All right. Why 6, Mateo? Because it's divisible by 2 and 3? Yep. So 6 because it's divisible by 2 and 3. So make sure you read how you should be writing those explanations. You guys cool with those? Okay. Let's talk about the word factors, because we are dealing with factors here. So I want to jump to what the word factors mean. It is important for you to know, recognize, and understand math vocabulary. So one of the terms that I want to make sure we understand are factors. What operation goes with factors? What operation goes with factors? Jack? Multiplication. So factors are involved in multiplication. So the best way that I'm going to show you and then give you the definition. So 2 times 3 equals 6. 2 and 3 are both factors. What is 6 called? What is 6 called? Aaron? That's a product. Alright, so if I was to write a definition, again, I never want you guys to memorize a canned definition. If I tell you to define something for me, I want you to define it in your words, because your words are what you're going to understand the most. So somebody explain to me, if you know 2 times 3 is 6, and 2 and 3 are factors, how would you define factors? Frankie? Excellent. I like that. The numbers that make up the product in a multiplication problem. Someone else give me what you would say is the definition. I'm going to write or here. How else might you, if you were teaching a little kid about what factors are, Layla? Excellent. The numbers that are being multiplied to get the product. So I really like that you guys just have an understanding of what something means, not memorizing a canned definition. Okay, so let's see one way that we could use factors. I'm going to say using factors. Okay. How do I find the area of a rectangle? How do I find the area of a rectangle? Mateo? Excellent. Length times width. So length and width are both factors. How many of you guys are in or know somebody in yearbook? Either you're in yearbook or you know somebody in yearbook. Awesome. Okay. If you're in yearbook, what are you doing with the pictures in yearbook? What's one of your jobs in yearbook when it comes to the pictures? Excellent. All right, so you need to make sure that you're laying it out so it all fits on the page, right? When you're laying out pictures on a page, do you guys pretend you're in yearbook? So this is not just a question for people in yearbook. So I want you all to pretend that you are laying out in Mr. Brogan's class because you're creating a yearbook page. You've all been given a job of creating a yearbook page. and you're laying them out on a page, would you lay them out all just kind of randomly, or would you have some, yeah, you can put them there. Would you put some organization to them? How might you organize them on a page? All of you are thinking about this. You're on your book. I've given you as an assignment, every one of you is designing or coming up with your own yearbook page. All right? You've been given a class, and you have to put all their pictures on a yearbook page. How do you think you might organize that pictures on a yearbook page? Talk to someone sitting by you. How might you organize pictures on a yearbook page? So you have your homework, you've got your homeroom. All right, how might you lay them out on a page? What might you do? I have D4 students. I've given all my D4 students the goal of laying out their pictures of all the kids on the yearbook page. How might you lay them out? There's not one right or wrong answer to this. I'm just wondering, how might you lay them out? Christian.
So, like, you can put them all in boxes next to each other, and the teacher, back in the class, you could put pictures of what you did during the year around the pictures of the class from, like, yesterday, and, like, snippets and picture art and the day of the class.
Nice. I like that. All right, when you put the individual students' pictures, right, with their name underneath it, would you have a pattern to it? Would you have, like, all the same number of pictures in each row? Would you have them where you have, like, kind of like an organization where it might be, like, kind of like a pyramid, like the most, and then it kind of goes down from there? How might you do it? Just curious, how might you guys do it? Erin? Evenly. So take each picture and have like 5 pictures in each row. And then if there are a couple left over, maybe 2 at the bottom or 3 at the bottom. How many of you guys think that might be a good way to do it? Organize it so you have like 3 rows with 5 pictures in each row or something. How many of you guys agree with that? Okay. That's what we're talking about today. Is I want you guys thinking about organizing pictures on a page. Or you're putting the chairs out. Okay, somebody needs to come. Thank you, sweetie. You're putting chairs out for the performance tomorrow. All right, you want to have the same number of chairs in each row. That's what we're going to be talking about. All right, so one way we can use factors, we want to arrange items in rows. Yeah, thank you. We want to arrange items in rows with the same number of items in each row. This is one way that we can use factors. Is that we want to arrange items in rows with the same number of items in each row. So let's do an example so you know what the heck I'm talking about. Who needs to see what's up there? Okay. So let's say we are creating a yearbook page. So when I went to school here, we had 36 students in a class. Okay, you guys have 19. We had 36 students in each class. Layla, your dad had the same when he was here. It was a lot. 36 students. So let's say we are creating a yearbook. We have 36 students in each class. We want to determine all the possible arrangements of the student pictures on the page if we want to put the pictures in rows with the same number of pictures in each row. So essentially when we do this, we are creating rectangles. So when we do this, what we're doing is we're creating rectangles. So let me explain to you what I mean by that. So if I look at, use grid lines, 1, 2, 3, 4, 5, 6. So I have 6 rows. So use your grid lines, each one is 6. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I have 6 columns. And I have now created 36 squares. How many of you guys see that? All right, so now what I've done is I've created a rectangle that has 36 squares in it. 36 pictures. So what we've done is we've created a rectangle of 36 squares or pictures. We have 6 rows and 6 columns. 6 times 6 is 36. So this number of pictures, that is the area of the rectangle. And our factors are the number of rows and columns. And our number of columns is our number of pictures in each row. Can you see how that works? So I have 6 rows, and I have 6 pictures in each row, 6 columns. So the number of pictures is the area. The total number of pictures that we want is the area. And one possible combination is 6 rows with 6 pictures in each row, or 6 columns. What's another possible combination? So if I look at 36, this is 6 times 6. What's another set of factors of 36? So I need to look at factors of 36. We already did 6 times 6. What's another set of factors? And I'm going to write this. Let me rearrange this. I'm going to write rows and columns. And the columns are the number of pictures in each row. So we have 6 rows, 6 pictures in each row. 6 times 6 is 36. What's another set of factors of 36? Come on, what's another set of factors? This is when you use your divisibility rules. What's another set of factors of 36? Angela? 3 times 12. 3 rows with 12 pictures in each row. Give me another set of factors. Kira? 4 rows, 9 pictures in each row. Give me another set of factors. Pierre? Jack? 18? Yep. So 2 rows, 18 pictures in each row. Well, could I say 18 rows and 2 pictures in each row? So while those two are the same factors, because we're dealing with rows and columns, we can flip it and it looks totally different, doesn't it? So what's another set of combinations? Remember, these are all the possible combinations of how we can arrange them on a page. 6 rows with 6 pictures in each row. 3 rows with 12 pictures in each row. 4 rows with 9 pictures in each row. 2 rows with 18 pictures in each row. 18 rows with 2 pictures in each row. What other possible combinations do I have then? Romano? We have 1 row of 36. What else? Alex? Excellent. 12 rows with 3 pictures in each row. Give me another one. Mia? 9 rows with 4 pictures in each row. Give me another one. I think we have another one. So I have 6 and 6. How about, we did 3 and 12, and 12 and 3. 4 and 9, and 9 and 4. 2 and 18. I think that's all of them. How about 36 and 1? 36 and 1. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 possible combinations. God bless you. Questions? All right, I'm going to have you guys do this again. But now we're going to have a little bit, let me ask you something. If you were arranging that page, are any of those combinations that you're like, we would never do that? So look at all the possible combinations and look and say, that totally would look dumb on the page. Are there any that you would say that about? Here? Great, 36 rows, 1 picture in each row. That would look kind of silly, wouldn't it? What else? Christiana? How many of you guys agree 1 row and 36 pictures? Okay. Is there any other one that you're like, I don't know that I would do that one either? Mateo? Yeah, maybe 18 rows and 2 pictures, right? So as if I was the editor of the yearbook page, I might say, figure out all the possibilities, but then I might put limitations on it, right? The number, you want to have limitations like, well, I want to make sure that I have at least more than 3 pictures in each row, or something like that. So we can put limitations on this while we come up with all the possible combinations. Then we can say, okay, let's limit them so it doesn't look dumb. Does that make sense to you guys? So I'm going to show you one that's like that. And I want you to do this. Now, when you're doing this problem, you need to come up with all the possible combinations and then circle the ones that meet the qualification. Does that make sense to you? Okay, so you guys are going to do this one on your own or with someone by you, and then we're going to talk about it when you're done. So with our winter or our Christmas pageant going on this week, this is a good one for you guys to think about. Now, when you set these up, I do want you saying rows and then pictures in each row. Like you could write column, but I want you to attach that column to how many pictures or how many seats are in each row. Okay, your rows will always be rows. Your columns are going to be how many of those things are in each row. So please write that as part of your explanation. Remember, write all the possible combinations and then limit it based on what they say there.
Good morning. Pardon the interruption. Would all band kids please report to the gym? All students in band, please report to the gym. Thank you.
Okay. So what number am I finding the factors of? So what number am I finding the factors of? Angela? No, what number am I finding the factors of? 20. All right. So Angela, I'm going to write rows, and then I'm going to write columns, but underneath that I'm going to say number of singers in each row. Okay, give me the combinations, Angela. Excellent. Excellent. What else? Excellent. Excellent. Yeah, two more, I think. How about 1 and 20? Right? And then 20 and 1. Don't forget those as possible combinations. Excellent job. So tell me, now that Angela's done the beginning part of that work, what's my limitation here? What's the limitation they've told us? Mia? Yep, I have to have at least 5 students in each row. So, I'm looking at my number of columns to determine that. So, Mia, which ones don't meet that qualification? This one doesn't, because there's only 1 student in a row. I'm just going to cross that out lightly. What other ones don't meet it? Alex? 5 and 4. There's not enough students because I can't have 4 students, can't have 1 student. How about, is there any more? Kira? 10 and 2, because I can't have 2 students. I'm going to lightly cross that out. All right, so the question was, what are the possible arrangements? So these are my possible arrangements. So I'm just going to circle the possible arrangements. And that answers it. Having all of them there, crossing out the ones that don't, or circling the ones that do, these are my possible combinations. 4 rows with, and don't just say columns. I want you to understand that columns means number of singers in a row. So 4 rows, 5 singers in a row, 2 rows, 10 singers in a row, 1 row, 20 singers in the row. Kira. No, this is all I'm looking for. If they say how many possible combinations, I would write 3 possible combinations. They've asked us for the arrangements, and because I have organized it in this way, I can state the arrangements right there. Layla. No, I'm good with this. Yes. Well, am I coming up with an equation? So the only reason why I write game plans is if I'm writing an equation. As long as, Kira, Layla, this goes back to you. As long as this says number of singers in each row, I'm good with this and you circling them and indicating this is your answer. If this just says rows and columns, then I need you to explain, all of you, what this means. Do you guys understand? All right, so Kira and Layla, you asked that question. If this does not say number of singers in a row here, then I need you to explain your answer. But this says rows and this says number of singers in a row. I'm good with that. Frankie. No? Huh, that stinks, doesn't it? Okay, we'll put a pin in that. Come ask me a question when you need to, okay? All right, you guys can go.